Now we're going to talk about hypothesis testing. In this shorter video, we're going to talk about some of the basics of hypothesis testing, like the null and the alternative hypotheses and test statistics. All right, let's get started with some vocabulary. A hypothesis. A hypothesis is a claim or a statement about a property of a population. A hypothesis test, which we'll be conducting, is a procedure for testing a claim about a population, testing whether that claim is valid or not. Okay, so for example, in the 1980s, a company called ProCare Industries Limited once provided a product that was called Gender Choice to, quote, increase your chances of having a girl, was using a method called X-sort. If we were to look at 100 couples using this method, what can we conclude if we observe that 52 couples have girls? Well, we would expect that the chances of having a girl or a boy would be 50% or 0.5. So out of 100 couples, 52 having girls does not seem statistically significant. So a claim that 52 couples having girls out of 100, quote, increases your chances of having a girl would be invalid. However, what if we observed that 97 out of 100 couples had girls using this method? Then we might agree with the claim that this method did increase chances of having a girl. Okay, let's practice a little bit of vocabulary right now because we'll need to be converting English into mathematical statements. So let's do this. Let's let G represent your grade in statistics class. We're going to translate the following into mathematical statements. Number 1, your grade is less than 90%. So that could be translated into G is less than 0.90. Now let's try this one. Your grade is at most 90%. That means that 90% is the highest your grade could be, but your grade could be 90% itself. So this would be written, G is less than or equal to 90%. So at most means less than or equal to. Your grade is at least a 90%. Well, that means that your grade could be 90%, but it also could be higher than 90%. So that would be translated, G is greater than or equal to 90%. Make sure you have these conversions down pretty well in your notes before you go on to the next section. Okay, let's talk about what we call the null hypothesis, excuse me, and the alternative hypothesis. The null hypothesis will use the notation H sub 0, but people usually don't say H sub 0, they say H naught. And the naught is the word N-A-U-G-H-T. It means nothing. H naught is a statement that the population parameter has an equals to in it, has an equality in it. So it's either equals to, less than or equal to, or greater than or equal to compared to some claimed value. It basically is the part of the statement where the value has not changed. So for example, the mean income of bankers is not more than $60,000. The mean income of bankers is not more than $60,000. That means that it would be, whoops, I'll read through the examples and then we'll go back and put the inequalities in. So the mean income of bankers is not more than $60,000. Another one would be the proportion of people aged 18 to 25 who use drugs is 20% or 0.20. And the third one is the standard deviation of duration times of Old Faithful, Geyser, is less than 40 seconds. Now let's convert these into the null hypothesis. The mean income of bankers is not more than $60,000. Since we're discussing mean, we're going to use the letter we've been using all semester, mu. Not more than means it's less than or equal to the $60,000. So we would say, since this has an equals to statement, our null hypothesis, with the equals statement in there somewhere, would be mu is less than or equal to 60,000. The proportion of people aged 18 to 25 who use drugs is 20%, is 0.2. So if you convert that into a math equation, your proportion would be P equals 0.2. Again, this has an equality portion to it, so this would be what we call our null hypothesis. P equals 0.2. And then finally, the standard deviation of duration times of Old Faithful geyser is less than 40 seconds. Well, this cannot be our null hypothesis because it doesn't have an equals to in it. It's just a less than. So the null hypothesis would be the statement that would include the equals to. In this case, that would be the opposite of that statement. The null hypothesis would be sigma, or standard deviation, is greater than or equal to 40. Okay, let's talk about the alternative hypothesis. The alternative hypothesis, the two common notations are either HA, which I like because it's A stands for alternative, but you'll frequently see in textbooks H1 for the alternative hypothesis. And this is a statement that the population parameter is different in some way from the null hypothesis. A lot of textbooks define these slightly differently. For us, let's go back to those same examples that we were using, and we're basically going to have the null hypothesis and the alternative hypothesis be the opposite of one another. So for the first one, all of our null hypotheses were the ones that had the equals to signs. The alternative hypothesis is the opposite of the null hypothesis. So if the null hypothesis was for the mean income of bankers, mu is less than or equal to 60,000. The alternative is the opposite of that. Mu is greater than 60,000. In the second example, if the null hypothesis is that the proportion is equal to 0.2, the opposite of that would be it's not equal to 0.2. And in the final one, the standard deviation is greater than or equal to 40 is the null hypothesis because it contains an equality. Then the alternative hypothesis would be that the standard deviation is less than 40. Please don't think that the null hypothesis has to be the claim that's being made, or that the alternative hypothesis has to be the claim that's being made. It doesn't matter which is the claim and which is not. One of them will be the claim and one of them will be the opposite of it. What is important is that the null hypothesis has the equal signs in it. The alternative hypothesis does not have equal signs in it. Okay. Let's do an example. We're going to just identify the null hypothesis and the alternative hypothesis for this following statement. An airline company claims that the mean weight of airline passengers, including carry-ons, is at most 195 pounds. Okay, remember the examples we were doing a few minutes ago. At most means less than or equal to. And since this is a mean, we'll use mu. So first thing we want to do is identify the specific claim and express it in symbolic form. So mu is at most less than or equal to 195. That's the claim. Its opposite would be mu is greater than 195. So write your claim in a mathematical statement. Write the opposite of the claim in a mathematical statement. The one that has the equals to sign is going to be the null hypothesis. That was the first one. So the null hypothesis will be that the mean is less than or equal to 195, and the whichever claim does not have the equals to sign will be our alternative hypothesis. Mu is greater than 195. Okay, a comment about one more vocabulary word, test statistics. A test statistic is a value that is used in making a decision about the null hypothesis specifically. And we're going to be calculating these test statistics based on the sample data that we're given in each problem. A test statistic is found by converting the sample statistic, such as the sample proportion or the sample mean, later on the sample standard deviation, to a score, a z-score or a t-score like you've been using in the previous two sections. Let me show you how we will be converting these sample proportions and sample means to z-scores and t-scores, to the test statistics. We'll be using these two formulas. The top formula, the t equals the sample mean minus the population mean divided by the sample standard deviation over the square root of n. This is the test statistic that we will be using when we're talking about means. So when we're talking about the mean of a population, we'll be using the t-score test statistic. Notice this test statistic deals with proportions. So when we're using an example dealing with a sample proportion, we'll be using the z-score test statistic. Z is equal to the sample proportion minus the population proportion divided by the square root of the population proportion times its complement divided by n. Please make sure you write these down, which one to use when. You use the t test statistic when you're dealing with a mean, a z test statistic when you're dealing with a proportion. Okay, let's do some examples. Consider the claim that the XORT method we were discussing before improves a couple's chances of having a girl. Let's just calculate the test statistic if we conducted an experiment with 14 births using the XORT method and 13 of them resulted in girls. In the following section, we will go through a full hypothesis test on this, but right now we're just going to calculate the test statistic. Okay, let's start by stating our claims and finding our null and alternative hypothesis. So the claim is that we are improving the couple's chances of having a girl. So the proportion is greater than 0.5. Then state the opposite. The opposite of p being greater than 0.5 is p being less than or equal to 0.5. Which one of these would be the alternative hypothesis? Would be the statement without the equality sign in it. So that would be p is greater than 0.5. And the null hypothesis is the inequality that has the equal sign in it. So p is less than or equal to 0.5. Okay, finding our test statistics. Since this is dealing with a proportion, we're going to use the z test statistic. So the sample proportion minus the population proportion divided by the square root of the population proportion times its complement. Remember, the population proportion should be 0.5. You should have a 50% chance of having a boy or a girl for the entire population. However, in this one, we had 13 of the 14 births were girls. So the 0.929 you see there is 13 divided by 14, the sample population. So the sample population is 13 divided by 14, or 0.929, minus the population proportion, which is 0.5, divided by the 0.5, the population proportion, times its complement, the 1 minus 0.5 is 0.5, over n, over 14. And when we calculate this, we get a z-score of 3.21. Now, hopefully, you remember enough about z-scores from the previous chapters that this should get you thinking of the standard normal distribution table and finding probabilities, and that's exactly what we're going to be using that z-score for in the next section. Right now, we're just going to practice finding these test statistics. Okay, let's do another example. A simple random sample of 25 filtered 100 millimeter cigarettes is obtained, and the tar content of each cigarette is measured. The sample has a mean of 13.2 milligrams and a standard deviation of 3.7 milligrams. Use a 0.05 significance level to test the claim that unfiltered cigarettes have a tar level of at most 14.6 milligrams, which is the mean for unfiltered 100 millimeter cigarettes. What do the results suggest about the effectiveness of the filters? Notice in this statement we're talking about means, so we'll be using the t test statistic. Okay, all we want to do in this example is find the null and alternative hypothesis and the test statistic. In the next section, we'll be going all the way through and figuring out what the results mean about the effectiveness. So first of all, state the claim. The claim is that the mean is less than, at most, less than or equal to 14.6 milligrams. Its opposite, then, would be that the mean is greater than 14.6. Okay. The null and alternative hypothesis, the one with the equality, the first one, less than or equal to 14.6, that will be our null hypothesis. And the one without the equality will be the alternative hypothesis. Mu is greater than 14.6. Finding the test statistic, again, since this is dealing with means, we're going to use the t-test statistic. So we have our sample mean. The sample mean was 13.2 minus the population mean. The population mean was 14.6 divided by the sample standard deviation of 3.7 over the square root of n, or 25.